Okay, we're going to be doing Chapter 2, Lesson 7. We're still working with solving absolute values, except for this time we're going to be solving absolute values with inequalities, which remember our inequalities are less than, greater than, less than or equal to, or greater than or equal to. Remember from our last lesson from 2.6, we said the first thing you have to do is make sure that you get the absolute value by itself. So there can be nothing added or subtracted, multiplied, or divided on the outside of the absolute value. Once we've done that, then we will set up our two equations and then follow our solving rules, which are distribute, combine like terms, add, subtract, multiply, or divide. We're also going to put them on a number line and then also interval notation, the solution set. So this first one says the absolute value of x is less than or equal to 3. So making sure that the absolute value is by itself, which it is. So we set up our two equations as x is less than or equal to 3, or x is, and now in the past we've only had to worry about changing that positive 3 to a negative. Because we're working with inequalities, we will also need to flip the sign. So it's going to be x is greater than or equal to a negative 3. So I come down to my number line. I have negative 3 and positive 3 both closed because they're less than or equal to, greater than or equal to. It's greater than or equal to a negative 3, which goes to the right, and less than or equal to a positive 3, which goes to the left. So I know that the solution is everything in between. So I would write bracket, negative 3, comma, positive 3, bracket. On the second one, again, I check, and there's nothing added or subtracted, multiplied, or divided in front of the absolute value. So I go ahead and set up x minus 6 is less than 2, or x minus 6 is, flip the sign, so greater than, and change the positive to a negative, so negative 2. Add 2 to both sides on the left would be x is less than 8, or add 6 to the left would be x is greater than 4. So come down here. This time the 4 and the 8 will both be open, pointed at each other. And so it would be parenthesis 4, comma, 8, parenthesis. On this third example, before we set up our two equations, we have to subtract the 1 because I need the absolute value by itself. So that would make the absolute value of 5x plus 1 equal to 9. So my first one I'll set up is 5x plus 1 is greater than 9, or 5x plus 1 is less than negative 9. Subtract 1 to both sides, which would give me 8. Divide by 5 on each side, which I'll just leave as 8/5. Subtract 1 to both sides over here, which would be negative 10. And then divide by 5 on each side, which would be negative 2. Put these on the number line. The negative 2 will be on the left. The 8/5 on the right. Both open. And this time the 8/5 is greater than, so that's pointed to the right. And the negative 2 is less than, so that's pointed to the left. So we have two separate solution sets here. So the first one would be parenthesis negative infinity, comma, negative 2 parenthesis. And the second one would be parenthesis 8/5, comma, positive infinity, parenthesis. Okay, on the next one, again, the first thing I need to do is subtract 5 to both sides. So that would leave me with 4 over here. And now I can set up my two equations. So I set up 3x minus 2 is less than 4, or 3x minus 2 is greater than negative 4. Add 2, which would be 3x is less than 6. Divide by 3, which is x is less than 2. Add 2 over here, 3x is greater than negative 2. Divide by 3, which is negative 2/3. Both would be open on the number line. X is less than 2 would go to the left. Greater than 2/3 would go to the right. So it's going to be parenthesis, negative 2/3, comma 2, parenthesis. Okay, our next one. We have the absolute value of 2x minus 1 is less than negative 13. So in the past with having them equal, when we did absolute value equations to a negative, that was a no solution. In this case, with being less than a negative number, that can't happen. So this one for sure would be a no solution, because we know that an absolute value can never be less than a negative number. It can't be less than 0. However, the tricky part would be if it said absolute value of 2x minus 1 is greater than negative 13, then that one would be our many solution. So if it's set greater than a negative number, you can solve it. If it's set less than a negative number, you cannot. And again, because your absolute value of a number could be something greater than negative 13. It could be 0, it could be 1. Those are all greater than negative 13. However, in the other case, it's a no solution because there is no absolute value that would ever be less than negative 13. So when it's set equal to those negatives, go ahead and check if it's less than, it's no solution, and if it's greater than, it's many solution. This one's kind of tricky because you see that it's set to a negative. However, if I follow rule number 1, which says that my absolute value cannot have anything added or subtracted behind it, the first thing I would do was plus 7. And once I did that, I've had x divided by 3 minus 1 would be now greater than 2. So then I would set up x divided by 3 minus 1 is greater than 2, or x divided by 3 minus 1 is less than negative 2, and those will be ready to solve. Our last slide just said make sure that you read the answers in interval notation, which we already have been doing here, this one. We didn't do it for the last one because we didn't solve, but the rest are good. And so you're ready for your homework.